Thevenin's theorem, because obviously for some reason I didn't save this, so I'm just going to take you through a little video on how to do it. So basically it's a way of starting with a potential divider, and then you'll end up with a single power source and a single resistor called the equivalent resistance. Okay, and then it makes it easier, obviously, when you connect things to the output. So the first thing to do is to work out its VOC, standing for open circuit voltage. So the open circuit voltage, and it's basically very easy. It's just basically it's just ratios. So in this particular case, as you can see, there's 5 kiloohms. There's 5 lots of 15 kiloohms times your 9 volts. 3 volts. Dead easy. Look at that. 5/15 of 9. Okay, that's step 1. Once you've done that, we find the short circuit current. That's what SC stands for. SC, think about it, short circuit. So that's what it means. When you see that, then try and think, well, short circuit means you put a wire somewhere because you short circuit the circuit, essentially. And in this particular case, you short out the bottom resistor. So step 1, you find the voltage across the bottom resistor. Step 2, we short out the bottom resistor. Therefore, the current is only going through the top resistor. Use Ohm's law, V equals IR, or I equals V over R. So 9/10 is 0.9. Don't forget, because you've got kiloohms, we come out in milliamps at the bottom there. So 0.9 milliamps. Cool. Step 2 done. And then step 3, we work out the equivalent resistance. Some books, I've said this before, instead of using R with the little zeros, they use R with an E and a Q for obvious reasons. There you go, like that. So equivalent resistance. You could use both. VOC over ISC, Ohm's law. It's all Ohm's law, isn't it, this whole thing? 3 volts over 0.9 milliamps gives me 3.33 kiloohms. Notice now, from the first circuit we've got for step 1, it now equates to this circuit here. Now, just be careful. When you draw this circuit here, you're using VOC for the power supply. You're using RO for the equivalent resistance. And then obviously this is V out here. So really, I should kind of write it over here. Let me put an arrow there, make it a bit clearer for you. That is V out. That's the output. Okay, the output terminals. Normally, you would put a resistor across the output terminals, as we will find out. Skippy, skippy, skippy. Okay, so those two circuits are the same. So what I've done is I've stuck a 3.33 kiloohm resistor across the output terminals of the first one. As you can see, it will give me 1.5 volts. Now, that would be quite tricky to work out. What you'd have to do is work out, obviously, you'd have to use the resistor in parallel equation first, and then find the current, so on and so forth. Whereas this one, dead easy. Look, you can straight away see, well, the voltage out is 1.5 volts, and that's because obviously the V out is essentially 3.33 over the total 6.66 times your voltage. You know it's going to be half of the voltage. Dead easy. It's really easy to find out. So that's why this equivalent resistance, Thevenin equivalent circuit, is really, really cool. Okay, so that's the kind of thing the examiner will ask. If you want, you might want to pause me now, write this down on a bit of paper, go all the way through. Notice the last bit says a potential divider, which is this circuit here, is loaded with the 2.4 kiloohm resistor. What that basically means is the 2.4 kiloohm resistor is going there. That's what it means, 2.4 kiloohms. Okay, so you might want to pause me now, work out all of those bits, and then unpause in a second. Okay, so VOC, dead easy. It's 3/5 of 10. Look how easy this is. Look at that, 6 volts. Short out bottom resistor. Well, V over R, 10 volts divided by 2K gives me 5 milliamps. This is going to be 6 over 5 is 1.2 kiloohms. Now, I've chosen nice numbers, so have a look what's going on here. So I've got 6 volts there. I've got, what have we got here? This was the, 1.2, isn't it? 1.2 kilo ohms there. I've got 2.4K there. So it's basically what is the output voltage. The output voltage is the voltage across here. This is my output voltage across there. Just label that V out. That's the output voltage there. So it's basically 2.4 lots. So let me write V out equals, you can probably do this in your head, 2.4 lots of 3.6, because that's the total resistance, add them together. It's basically the same as step 1 there, isn't it? Look, times your 6. Well, look, I could do that in my head. It's going to be 4 volts. Done. For step 5, I suppose this is step 5, they can ask you different things. So they can give you a resistor, and then they can ask you to find the current and things like that. But it's just series circuit rules. In a series circuit, the current stays the same, and the voltage is shared amongst the components and adds up to 6 volts in this particular case. I don't think I need to do any more on Thevenin. So